A very good morning to one and all. So we are going on to the next lecture. It is implementation of MATLAB functions using embedded MATLAB function blocks, Simulink. And we have with us our expert, Dr. Vijay Nehra. He is Director, University Placement and Counseling Cell. He is the Chairperson of Department of Electronics and Communication Engineering and Applied Science. And he is Professor and Head there in the ECE department. Uh, in the BPS Mahila Vishwavidyalaya at Sonipat. So I welcome him again to this course on STZ on MATLAB and its hardware interface from 11 to 15th. This whole week it is going on, and our expert, he is even the expert in the S function. So because everyone, we are afraid of this S function. Whenever we think of S function, we don't do it. Sir is there. Even the afternoon session, he'll be handling the S functions for us. And now I hand over the session because we are getting late also. So I'm just handing over the session. Thank you.
Thank you. Very good. I hope discussing implementation of MATLAB on the treatment Simulink. In fact, when we come to this Simulink user-defined library, our focus is on customized application. So the agenda for discussion is steps for engineering problem solving methods, how we create these embedded MATLAB function blocks and its application in different problems. So the first thing is one should be very clear with what are the steps for engineering problem solving. There are 5 steps. The first step is you have to define your problem clearly. Then you have to identify the input and output parameters for your problem. Then you have to obtain the analytical solution of your problem, that by hand. And the next is you have to obtain the MATLAB solution of that problem, either by using this text programming environment that you can say using MATLAB script implementation, or using graphical programming solution using Simulink. And the final step is you have to verify your result. Right? In fact, throughout this embedded MATLAB function blocks, we focus on these steps. You take any problem from any domain, you have to identify your problem, input parameters for your problem, output, then you have to look for the solution. And there is not only embedded MATLAB function blocks where you can find the solution of the problem. There are multiple ways where you can implement your problems to find the solution using this scientific computing. So before coming to this whole this embedded MATLAB function block, one should be very aware. How can we use these scientific computing tools for problem solving? One can use either a package as a textual and graphical programming environment. One can use open source or this commercial package like MATLAB. One can have an option to use programming language. And if you use a dedicated package, then you have a here we focus on general purpose scientific computing for implementation. use this general purpose package MATLAB for this simulation. In fact, before going to there are a number of use of that package. You can use at various levels, either as a teaching tool, or you can focus in solving engineering problems. You can use it in handling data in your lab. There are multiple ways a user can use this. Then the very important thing is how we assimilate or how we use this package when we use this package. In fact, in most of the universities, it is integrated horizontally and vertically. You started using it from the first semester or first year along with C programming, and then you use it vertically across all domain of your curriculum.
Hello, excuse me, your voice is not audible here. Can you please adjust your voice? Volume of your voice.
Hello? Hello?
Hello? Excuse me, it's not audible here.
Hello? Hello? Is yours? Is it yours? Yours? Anji sir, am I audible to you? If you ask the mic number. Okay, sir. Thank you, sir. Hello, at Yaten Bara. Hello. Hello, hello. Hello, yes ma'am, now I'm audible to you.
Yes, yes, sir, it is audible now.
Okay.
But after you have extend over here.
That's because of your internet issue.
You have
So you can use this package horizontally and vertically across your curricula. And if you are from the domain of electronics and communication engineering, you can use across all subjects, starting from the basic science to the even digital signal processing, communication signal and electronic devices, and circuit control system, circuit and system for minor and major project. This whole discussion starts from this slide onward, and the first thing is the M files in MATLAB. There are basically two types of M file in MATLAB. One is script file that consists of a sequence of MATLAB command, and the second is function file. There is a difference between script file and function file. The function file accepts input and output argument, and it returns output argument. Both the files are stored with .m extension, so both are known as M file. And as far as the execution of these script and function file is concerned, then it is different. So the first thing is how we write a M file. The first thing is we open the MATLAB desktop environment, then we open the MATLAB editor window, enter the M script into the editor, save the M file script, and compile and run the MATLAB script. In fact, for this embedded MATLAB function block, we have to write this MATLAB function. So it is important to understand the structure of the function file. A function consists of a function definition line where it starts with a keyword function followed by output argument, which is within a square bracket, followed by this function name and the input variable, which is within parenthesis, not in square bracket that I have shown here. Then followed by this help line and function body, and finally it ends. So in case of a function, the first line is always function definition line, where you have to define, where you have to start with the function, output argument within a square bracket, then function name and the input argument within the parenthesis. And the next thing is, in order to execute a function file, first we go to MATLAB command prompt and type the name of the function and the input and out. The input variable is applied to the function and execute it. So this is an example how we write a M file script file, and simply you can type it in any text editor. You simply copy them in MATLAB editor and then run it. This is the way you can write a script. This is an example of a symbolic script. You can use symbolic methods of MATLAB and you can write this symbolic script. In case of a symbolic script, you have to define your
Hello.
symbolic.
Sorry to interrupt, sir. I am from DSS college, and still your voice is not coming properly.
Ma'am, the problem is at your end, because at other centers we have confirmed the audio is properly transferred.
Okay.
मैम आप ना आपके इंटरनेट में मैम मे बी फ्लक्चुएशन के कारण डिस्टॉर्टेड नॉइज आती है, इसको डेडिकेटेड रखिए.
सर, जो प्रीवियस सेशन था उसमें वॉइस वाज वेरी क्लियर, बट आपके सेशन में नहीं आ रही है.
दैट्स व्हाई मैम आई एम सेइंग कि जब फ्लक्चुएशन होती है तो डिस्टॉर्टेड वॉइस आती है.
ओके सर. हेलो. Hello. Can you please speak loudly? Because your voice is really not audible. For the participants.
मैम आई एम सेइंग आप अपने इंटरनेट की डेडिकेटेड रखिए और बाकी सभी जगह अगर आप इंटरनेट यूज कर रहे हो उसको बंद कर दीजिए, बिकॉज आपकी मे बी फ्लक्चुएशन हो रही है, इंटरनेट कम हो रहा है, बैंडविड्थ, तो डिस्टॉर्टेड आवाज आ रही है आपको.
डिस्टॉर्टेड वॉइस नहीं आ रही है, वॉइस स्लो आ रही है. वही
लो आ रही है मैम, देन स्पीकर्स का लेवल अप कर दीजिए.
ठीक है सर.
This is an example of a MATLAB script where we want to plot the time domain response of first order system, and if you look at this script here, we define it three functions. One is for step and then the other is for ramp and the other is for execution, impulse execution. This is the can we write this symbolic script where we use this symbolic toolbox where we declare the symbolic. If you look at this function file, this is the function file of the first script file. Here the difference is the first line is your function followed by within our square bracket output argument v1, v2, v3, followed by the name of the function RC response and the input parameter RC A1, A1, A2. So this is a script which is converted into a function file. Here the input arguments are R, T, A, A1, A2, which is clearly stated, and the output is V1, which is time domain step expression out, the time domain response, ramp response, impulse response, and then we write the expression for time constant, and then we plot. So here we have clearly specified the input argument, and once you supply this input argument, you can execute. If I take a simple example how we execute this script, specify your input argument. R is supposed 2.5 into 10 raised to power 3. E is for 0.00. A is for 10. A1 is for 10 and 10. So apply this input argument and then this is the way to execute this function. If you look at your script, and I simply copy a script and I try to run. This is the how can we instead of right side. です。で、こっちで、で、0.0 is to dictate. So the first thing is you have to understand the difference between a script and function file, because for writing embedded Matlab function block, you have to write function file, not script. This is the first thing that you have to do. Then, in case of embedded Matlab function block, we have to write the code into this embedded Matlab. So the first thing is you have to understand the specs of the general Simulink model. A Simulink model also always source is the signals are used to excite your system. A system is an interconnection of object that you design, and the sync is this right for now. That is not going to. Yes, in case of Simulink, there are 16 library, and your focus is on your 15th library, that is user-defined function library. This user-defined function library. This is this 15th library in Simulink group of library, and it is used to create customized functionality. And in case of this user-defined function library, it contains function block, FCN block, it applies a specified expression to its input, denoted as U. Matlab FCN block applies a specified Matlab function for expression to input. And we have a embedded Matlab function block. Some of the blocks of user-defined function library allow Matlab programming, and other allow programming language in certain blocks. If you look in case of user-defined library, we have a embedded Matlab function block and S function block. S function blocks allow programming in Matlab as well as in C, C++, ADA, Fortran. Whereas if you look at this embedded Matlab function block, it allows only Matlab language function file. So this block accepts multiple input signal and it produces multiple outputs. If you want to create a Simulink model using embedded Matlab function block, what you have to do? Firstly, look on the steps of engineering problem solving method. Find your input and output parameters. Then open a Simulink model window. This copy this embedded Matlab function block. Double click on this embedded Matlab function block. Embedded Matlab editor window will appear, and on in embedded Matlab editor window write a function file, and then you save it and then execute. So this is an example photocurrent for computing this photocurrent of a solar cell. And if you look at the mathematical equation governing this photocell, then the equation is this ISC plus KI into minus PR into S. This is a fundamental equation corresponding to this photocurrent of a solar cell. So what we do to create embedded Matlab function block for this, firstly we write a function file. So we write a function with name photocurrent, and the input argument to this function is short circuit current, this KI, this T, reference temperature, and solar irradiation. And the output of this function is your IPH. This is photocurrent. And in case of a single output, there is no need to enclose it within a square bracket. So when you write function, the first thing is define what is the purpose of this function. So this function is used to compute the photocurrent of a solar generator. Then find out what are the input argument for this function. The input argument for this function is ISC, KI, P, PR, and this solar irradiation. Then the output is photocurrent. Then open your embedded Matlab editor window and paste this function there, and then run your model. So it will create a Simulink model that is shown here. I will take example. Just the first thing is I try to show a number of examples. Then the second thing is, if you want to create the compute the reverse saturation current of a solar cell using embedded Matlab function block, then again the steps are the same. What we do? Firstly, we write a function file, and the name of the function is reverse saturation current. It takes input argument ISC, Q, VOC, NS, A, AT, and it compute IA, RS. We firstly write a function file in the syntax of the MATLAB, in MATLAB language, then we copy this function file and we put it into embedded MATLAB function block. Or you have an option, you can go into embedded MATLAB function block and you can write there. It's up to you. This is the way how can we look into the solution of the problem using this embedded MATLAB function block. We want to compute the reverse saturation current of a solar cell using embedded MATLAB function block. So look on the 5 steps of engineering problem solving methodology. Firstly, describe the input and output for this problem. The input for this problem is short circuit current, electron charge, open circuit voltage, number of cell in series, Boltzmann constant, this ideality factor, operating temperature, and output variable of the function is ISC, reverse saturation current. So the second step is to define these input and output variable of the function. Then develop an example. Here you focus on the analytical solution of the problem that you can solve it with by hand. The next thing is develop a Simulink solution. What I told in the first slide is in the 4th point. You can obtain the solution of a problem either using text programming environment or you can obtain the solution of a problem using graphical programming environment. Here we are obtaining the graphical programming using Simulink, the solution of the same problem. So one can also use MATLAB text script implementation to solve the same problem. Here we can also use this text script implementation or we can test the result for a variety of data. In fact, not only this by using this Simulink, there are multiple ways where we can look on how can we find the solution of the problem. In 4th step where we go for the MATLAB script implementation. What I told you is you can use MATLAB text programming environment. Here you require the MATLAB script implementation. It requires the knowledge of programming. Then you can find out the solution of a program using graphical programming environment, model-based design. Here you require the knowledge of Simulink library and graphical programming solution. Then you can create the basic Simulink model that you can create mainly using blocks of source, sink, and commonly used block library, math of fiction library. You can create Simulink model using tags of Simulink routing library. The same solution you can create using from and go to tag blocks of signal routing library. You can model using physical component, Simscape library. You can find the solution. You can model using advanced component in sim electronics. And then you can find out the solution of the same problem using embedded MATLAB function block of user-defined function library. Here in case of embedded MATLAB function block library, you require the knowledge of writing MATLAB function. And you can find the customized solution of the same problem using S function blocks of user-defined library, where you have an option to use S function level 1 S function block, level 2 S function block, S function builder block, and you can use this level 2 implementation of this S function block using C or ADA. So I just try to take one example. So first thing is to create the Simulink model of photo current. What we do, we go in Simulink library and firstly we copy this embedded MATLAB function block. In case of this new version, it is MATLAB function block. In earlier version, it is embedded MATLAB function. So you copy this embedded MATLAB function block, double click on embedded MATLAB function block. This is your embedded MATLAB editor window where you write a function file, and here uh, I just take one function file that I have already written. This is one function file. I simply copy it and paste it here, save it. Autocorrect. Close it. So what you find, this is your embedded matrix function block. Here it is created with the number of inputs that we defined in the function and with one out. So what we do, then we give it, we define the input and output of the function. So we go to the source library, take a constant block, and in library take a display. So now come on this, you look at this Matlab function file. The input for short circuit current is 3.74. This 3.7. This is KI 0.17. To 88, 328 in the step of 10, 288, 10. It is a vector. There is reference temperature is 98 and now this is your complete embedded matrix. So go in your and your this is how to get. So the basic thing in embedded Matlab function block is writing a function file.
हेलो हेलो
तो ठीक है
सर फ्रॉम आरटी कोटा
तो ठीक
हेलो
And
हेलो
ठीक है तो क्लैरिटी है
हेलो हेलो फ्रॉम आरटी कोटा सर सर ये आपका जो प्रोजेक्टर है इसको थोड़ा फोकस कीजिए, थोड़ा सा कम ब्लड दिख रहा है ये। नहीं आपकी वॉइस भी नहीं आ रही है हमको ढंग से, और क्या आपको ये ब्लड दिख रहा है थोड़ा सा, ठीक है फोकस नहीं आ रहा साहब।
सर ये यहाँ से फोकस्ड है हमारा, ये ऑनलाइन ही आपके एंड पे ट्रांसमिट हो रहा है, ये जब रेजोल्यूशन कम होती है, जब इंटरनेट स्पीड कम होती है।
ठीक है सर।
अब अगले ने दे दिया जवाब।
जवाब
दूसरा आगे हमारी गलती नहीं, तुम्हारी
वो
गलती
नीचे
है।
So this is your first problem where we create the embedded MATLAB model for computation of photo front of solar cell. Now, if you focus on this problem, again, if you want to find out, we want to create the embedded MATLAB function flow, we proceed again in the same way. What we do? Close it. Open a blank model window. Go in user-defined function library, copy this MATLAB function block, and take your input and output. For output, we take a display. For input, we again take a source. Double click on this MATLAB function block. This is your embedded MATLAB window. Now look on the problem. This is the problem we want to compute the reverse saturation current of a solar cell. So I have already written the function file for the same. Copy this function file. Again. Paste it here. This is your function. The input argument to this function is ISC. So we use NS A, E, and the name of the function reverse saturation current, and the output is your reverse saturation current. This is called comment. Input to the function ISC, Q, open circuit voltage, Boltzmann constant. Output variable is your reverse saturation current, and this is your function that we have defined in language of MATLAB. The syntax that we use. Close it. So your what you have to do is short circuit current is 3.74. Electron charge is 1.6 every standard or minus. Define 1 Then take quickly the step now save this one. You can avoid this configuration inside this UI. Automatic parameters, automatic solver parameter selection none. This is an example. You can take an example from digital electronics where you can verify the table of 3 input AND gate, OR gate, and XOR gate. Again, for the same, what you have to do is open the blank model window, copy embed MATLAB function flow, then copy your function or write a function, whatever you want to write in embedded MATLAB function flow. So simply take an example. More complex, as complex as possible. Compute this module saturation parameter and the mathematical equation corresponding to this I have noted. Error. The first line is always a function definition line, which is always starts with keyword function, followed by output argument within square bracket and then function name and the input. So this is again an example. If you look on this function, firstly what we are taking the reciprocal of, we want to compute 1 by t minus 1 by tr. So 1 by t is taken as y1, 1 by tr is y2, y3 is y2 minus y2. And then we compute this 1 by t minus 1 by exponential of q qc 1 by tr minus 1 by ta. Write this equation. Okay. Again, in the similar way, you have to take the input. This from you can take either from commonly used block library or from the source library. Constant. Things like mobility of electron and hole of difference at which are
Hello? Hello, sir. Hello, sir. I am from JS College.
Half adder, full adder, and half subtractor and full. So what we do, first we focus on its half adder, and what it needs two input, and full adder needs three input. So how many input we need to, if I want to realize both it simultaneously? 5 input, 2 for half adder and 2 for 3 for full adder. So and how many output we get? For half adder we get 2 output, and for full adder we get full adder we get 3. 2, 2, 2. So 2 plus 2, there are 4 output, and how many input? 5 input. So suppose we write a function, and we started with function, and output is your x1, y1, x2, y2, and function name is half full, and input is your input is x, 5 parameters. Suppose you a, b, c, d, e, 5 input. In order to compute these 8 outputs, I have to use loop 4. So in half adder I use it 4 times, and in full adder I use it 8 times. There are 8 inputs to compute the output first. So that is the reason. So what we do, the usage is to make it as a half adder and full adder, and the input is input. There are 5 input: A, B, C, D, E. All are logical input. Yes, you have to write a code. Yes, whatever you want to do with embedded MATLAB block, the first requirement is what you have to write is a function file. A function file. So if you want to realize it using two half adder, and then you want to create a full adder, so what you have to do, you have to write a half adder. Whatever you have functionality, you have to implement for half adder, and then you can proceed. No. Nesting is possible. You can connect one after in a cascade manner. That is, you can do. There are certain model, like in case of photo current, where we have a number of equations covered photo cell. So what we do, we create a embedded MATLAB function for one. Like that, I have taken an example. One is for photo current, reverse saturation current, module current. So they can be used in any manner wherever required. This is an example of a to compute the mobility of a electrical conductivity and resistivity of, and the input that is given are is mobility of electron and hole, and density of electron and hole density. So what is the mathematical relation to compute the conductivity? N into E into mu I plus mu. So that function name is resistivity 1, input is ENI, this first input argument, second input argument. There are 4 input and 1 output, and this is the mathematical function how we define. Again, copy this function into your embedded MATLAB function flow, provide the input, and run your. This is one of the examples to compute the capacitance of a varactor diode. Simply you use the mathematical relation of computing the capacitance of a varactor diode, epsilon A bar, and write a function for the same. Your function is name is varactor diode, input argument is output is this, and again paste this embedded this function file into embedded MATLAB function. So these are 3 inputs, and one is your output. Logical operator. Suppose you want to verify the truth table of your AND, OR, and XOR function. So what we do, there are 3 input. This is the name of function. F1, F2, F3 are the output, and this is the name of the function. Inputs are X, Y, Z. These are 3 input which is written. Output is F1, F2, F3. We use a for loop for m equal to 1 to 8. F1 equal to X and Y and Z. F2 is X or Y or Z, and F3 is X or this is the firstly we write for X or for X and Y, Z, and this is X. What we do, we copy it and we provide this logical input. This is logical. By how we provide the binary input, this constant block is we write that syntax logical within parenthesis and within square bracket we provide your binary input. So this is first binary input 0 0 0 0 1 1 0. This is second binary input and third binary input. This is your output. Take example. Copy again embedded MATLAB function to MATLAB, and as we want display source, what we have to copy your function file for the same, write it here. This is the function definition line and comment audio close. So define
कैमरा जक दे मैं इतना
one. Close this square bracket and parenthesis. Logical. Save. Truth table. So this is how can you create a embedded Matlab function block for the same. Save it, close it. This is one more example. The band gap energy for gallium arsenide is equal to 1.45. Planck's constant 62 into 10 raised to power minus 34. Speed of light is, this is 3 into 10 raised to power 8. Not 3 in 3 into 10 raised to power 8. Calculate the wavelength of emitted radiation of LED of gallium arsenide. Suppose we want to create embedded. We want to find the solution of this problem using this Matlab function block. What we do? Firstly, we write a function for the same. This is the function. Output is f. Name of the function is lambda. We define input argument. there are 3 input to this function, 1 output, and simply write this expression, f equal to hc upon az. Then how we create? We copy your embedded MATLAB function block from user defined library. MATLAB function block. Use this sync block for display purpose. User defined input from this constant block. Double click on this your embedded MATLAB function block. Embedded MATLAB editor window will appear again. Write a function here or copy already existing function. This is an example of this function. Double paste here. Close your embedded MATLAB editor window. Embedded MATLAB block will be created with the same number of input and output that we have defined in function. Give the input. Output. Provide the first input. And easy is 1.45. So in case of all example, any kind of problem, you have to proceed in the same way. This is an example of a how to realize half adder, full adder, and half subtractor and full subtractor. Here, these are two inputs which are for half adder, 2 inputs, and this is the combination of 3 input. This is expression for sum and carry that comes from half adder, and this is the output that comes from full adder, sum and carry, and borrow and difference and borrow from half subtractor and full subtractor. What you have to do is, firstly you have to look on the Boolean expression for sum and carry, difference and borrow. You have to write it in a function file using the syntax of MATLAB language. Then you have to copy this function file into a embedded MATLAB function block. You have to provide the required number of inputs and output, and then you have to run your Simulink model. This is an example how you create a BCD to XS3 code converter using this embedded MATLAB function block. Again, the steps are the same. Implement your M function file, copy the function file, and put it into an embedded MATLAB function block, run the model. The next thing is how we create a custom block library. A block library is a special Simulink model. What you do is whatever the model that we have created, we can put it into a block library. We can create our own customized block library. When a block is copied from a block library to a model window, a link is established from the library to your the model. A block in the block library is called a library block. A copy of library block in the model is called a reference block. The main block is that reside in your library that you have created is your library block, and that you copy it in your model is called reference block. Each reference block has its own data, but the functionality is defined by the library block. Yes, this is very important. Each reference block has its own data. You have to provide the, like if I create a embedded MATLAB function block for all the problem as a customized library, what I to do, I take these all embedded MATLAB function block into your new library and I put it there, then I provide a path. So these are the steps for creating a customized library. The first step is open a new library window by choosing File, New Library from any model window menu bar or the Simulink block library menu bar. The second step is copy the desired block to the new library. And the third step is save the desired block library. And the fourth step is you can add the directory in which the library is stored to the MATLAB path. So reference block can find only library blocks that are in the MATLAB path or in the current directory. Once a block library is created, customized block library, and if you want to change it or edit it, so once you create a customized block library, save it, it becomes locked. So once a block library has been saved and closed, it is locked and cannot be changed. If it is necessary to change the block library, either to add more block or to edit the block library must be unlocked. To unlock a block library, what we do? Choose Edit Unlock Library from the block library window menu bar. The library will be unlocked as long as it remains open. To relock a block library, choose the library and then reopen it. When a block in a library is changed, the change will be applied to each corresponding reference block when the model containing the reference block is open or run, or when file update diagram is selected from the model window menu bar. So I will take how we create customized library. This is an example where we have copied only three blocks. One is your saturation current, other is photocurrent, and other is reverse saturation current. This is a library that is created, and if you want to use this block, what you have to do again? I will take more. Yes. Corresponding to each problem, what I have carried out is I have created a customized library. I copied each block into this library, and if I want to create a new model, what I do? I use this. Suppose we want to use a simple block. We want to compute paste. This is an example to compute mean and standard deviation. So provide input and output to the block. Input through this constant block and display. So this block is copied from the library. This. You can take any block from this library. This is an example of a saturation current using the same problem using S function builder block that I take an example of this, suppose Hall coefficient. Provide the input and output. So if you look at this function file and you want to omit it, suppose it will not omit. This is, if you want to make the change, you have to make in your, this is reference block in main library block. So to unlock it, what you have to do? Edit, unlock library. Then you can make change here. So you can use any block of this problem. So in summary, it can be said that MATLAB function block is an implementation of MATLAB text-based description of M function file. It requires knowledge of MATLAB script implementation to build corresponding embedded MATLAB function block Simulink model. The MATLAB script implementation is a text-based M-file description of system under reference that can be written in any text editor. One can implement the MATLAB script and Simulink model as a computational project-based model that can contribute to improvement in learning. Well, you can take any example. You can write the same. You can use it as a pedagogical tool in any area of your choice. The MATLAB function block can only be used to express the static nonlinear function described as y equal to fu, not dynamical system. The system expressed by complicated differential and difference equation cannot be modeled in this way. As function modeling technique can be used to solve this problem, to model more complicated